On March 10th, 2026, at 6:23 in the morning, the ground at the summit of Kilauea volcano split open, not gently, not slowly. Within minutes, lava was fountaining over 1,000 feet into the air. 1,300 feet to be precise. That's higher than the Empire State Building, higher than the Eiffel Tower with another skyscraper stacked on top of it. A column of liquid rock screaming upward into the Hawaiian sky, visible from miles away, lighting the pre-dawn darkness like a second sun. And it went on for 9 hours. Most people caught a 30-second clip on social media. A few caught it on the news. And then the world moved on. But here's what the headlines didn't tell you. This wasn't a surprise. Kilauea has been doing this over and over again since late 2024. Short bursts, intense eruptions, brief pauses, then another burst. A volcano breathing fire in a rhythm that scientists are watching very, very closely. And directly next to it, sharing the same island, the same underground plumbing, the same volcanic hotspot deep in the Earth's mantle, sits Mauna Loa, the largest active volcano on the planet. Not erupting right now, but showing signs. This is the story of two volcanoes, one that's already erupting and one that's quietly, methodically refueling. Let's start with what actually happened on March 10th. Kilauea's eruption originated inside the Halema-Umayu crater, a pit within the summit caldera that has become the main stage for the volcano's recent activity. When the eruption began, it didn't build gradually. It came fast. Lava fountains surged upward almost immediately, and within the first hour, the crater floor was already being buried under fresh lava flows. The sky above the summit turned dark, not from night, but from ash. Thick plumes of volcanic ash and gas billowed outward, carried by the wind toward nearby communities. Roads closed. The Hilo Airport, one of the main airports serving the Big Island, shut down operations. Hawaii Volcanoes National Park, normally one of the most visited natural landmarks in the United States, sealed its gates and began evacuating visitors. But the lava itself wasn't the only danger. When volcanoes erupt at this scale, they throw something into the air called tephra. It's a broad term that covers any solid material ejected during an eruption. Ash, rock fragments, and glassy volcanic particles. Some of it is fine enough to breathe in. Some of it is sharp enough to cut. It can tear into skin, scratch corneas, damage lungs, clog air filters, and destroy vehicle engines if you're caught driving through a heavy fall. And then there's something called Pele's hair. Named after the Hawaiian goddess of volcanoes and creation, these are ultra-thin strands of volcanic glass, spun out of lava droplets as they fly through the air and cool almost instantly. They can be thinner than a human hair. They're so light they can travel for miles on the wind. And they look almost beautiful. Golden, delicate, like something you'd find in an art gallery. But if they land on your skin, they cause irritation. If you breathe them in, they can damage your respiratory system. During the March eruption, Pele's hair was reported in communities well outside the immediate summit area. That's the invisible reach of a volcanic event. Even after the fountains die down and the lava cools, the sky keeps delivering reminders. 9 hours after it began, the eruption stopped. The fountains dropped. The lava lake in the crater settled. The ash began to thin, and Kilauea went quiet. For now. Because here's the pattern that most people aren't aware of. Since late 2024, Kilauea has been erupting episodically, in pulses. An eruption starts, burns intensely for hours or sometimes days, then stops. The volcano rests. And then the pressure builds again, and it erupts again. Scientists call this cyclical behavior, and it's driven by the way magma moves through the system. Think of it like this. Deep below Kilauea's summit, miles underground, there's a reservoir of molten rock. Magma rises from the hot spot below, fills the reservoir, and when the pressure gets high enough, it pushes upward through cracks in the crust and erupts at the surface. The eruption releases that pressure. The reservoir partially empties, and then it starts filling again. Every eruption in this cycle is a little different. Different heights, different lava volumes, different durations, different hazard zones. Scientists at the USGS Hawaiian Volcano Observatory track all of it, comparing each event to the ones before it, looking for any shift in the pattern that might indicate something is changing in the system. March 10th's eruption was notably more powerful than several of the smaller events that preceded it in early 2025. The fountains were higher, the lava output was greater, the tephra dispersal was wider. Whether that represents a meaningful escalation, ND, or simply natural variation in an episodic cycle is something researchers are still working to understand. What they can say is this: Kilauea is not done. It will erupt again. The only questions are when, how large, and in which direction the hazards will travel. Now let's talk about Mauna Loa. If Kilauea is the volcano that's always on, on, constantly active, constantly in the news. Mauna Loa is the one that sleeps, but sleeps is the wrong word. It waits. Mauna Loa is the largest active volcano on Earth, not in height, but in sheer volume. If you measured it from its base on the ocean floor, it would be taller than Everest. Its flanks cover half the Big Island, and beneath it, the same volcanic hotspot that feeds Kilauea is also feeding Mauna Loa, a shared underground system that makes these two volcanoes geological siblings. Right now, Mauna Loa is not erupting, but its ground is moving. GPS sensors placed across its surface are recording slow, steady inflation. The ground swelling upward as magma pushes into chambers beneath the summit. Small earthquakes, too small to feel, but easily detected by seismometers, are rippling through its flanks in clusters. Scientists describe this as normal post-eruption recharge. The volcano's last eruption was in November 2022, its first eruption in 38 years. And after an eruption, it's expected that the system will gradually refill as the hotspot keeps pushing magma upward. This is not a warning. Scientists are not predicting an imminent eruption. But here's why Mauna Loa demands attention, in a way that Kilauea simply doesn't. Kilauea's eruptions, dramatic as they are, tend to be somewhat contained. The lava fountains are spectacular, but the flows largely stay within the summit area or move through established rift zones that scientists have been tracking for decades. The hazard zones are mapped, the risks are relatively well understood. Mauna Loa is different. When Mauna Loa erupts, its lava doesn't fountain straight up. It flows outward, across the flanks of the volcano, toward the sea. And it moves fast. In 2022, lava flows were advancing at rates that could outpace a walking person. Within hours of the eruption starting, they were threatening roads that connect the north and south of the island. A few more days of activity in the wrong direction and populated coastal communities on the west side of the island would have been facing direct lava inundation. Mauna Loa's lava can reach the ocean. It can reach towns. And when it does, it doesn't stop. There is no fire break for lava. There is no bulldozer big enough, no barrier strong enough. When it comes, the only answer is to not be in its path, which is why the monitoring matters so much. The USGS Hawaiian Volcano Observatory runs one of the most advanced volcano surveillance networks on Earth. Hundreds of sensors, seismometers, GPS stations, tilt meters, gas analyzers, thermal cameras, all feeding data continuously into systems that scientists review around the clock. The goal is not to predict eruptions with perfect certainty. That's not something science can do yet. Volcanoes are complex, dynamic systems operating on timescales and pressures that are difficult to model completely. What monitoring can do is give warning, days, sometimes weeks, of early signals that allow communities to prepare, evacuate if necessary, and minimize the human cost of events that are ultimately beyond human control. In 2022, when Mauna Loa woke up after nearly 4 decades of quiet, scientists had enough warning to alert the public well before lava reached dangerous proximity to communities. The eruption was closely watched. Evacuations were organized. And despite the scale of the event, despite rivers of lava pouring down the side of the world's largest active volcano, no lives were lost to the flows directly. That outcome was not luck. It was the result of decades of monitoring, research, and preparation. And it's the template for how humanity lives alongside active volcanoes in the 21st century. There are over 200,000 people living on the Big Island of Hawaii. Many of them live in officially designated lava hazard zones, areas where scientists have calculated that future flows are geologically possible, even likely over long timescales. And most of them know this. They make the choice to stay. That's not denial. It's a negotiation between risk and beauty, between science and culture, between what a map says is dangerous and what a family has called home for generations. Hawaiians have lived alongside these volcanoes for more than 1,000 years. The same eruptions that destroy roads and homes are the eruptions that built the islands in the first place. The lava that enters the ocean today is the coastline that will exist in 100 years. Kilauea is not an enemy of Hawaii. It is Hawaii. The science exists not to scare people away from these islands, but to give them the best possible chance to live on them safely, to watch, to warn, to understand a little more each time the ground opens up and the Earth reminds us of what it actually is. A living, dynamic, restless planet that was here long before us and will be here long after. Kilauea will erupt again. Mauna Loa will erupt again. And when they do, the scientists watching the screens will already know it's coming. Now I want to hear from you. If you lived on the Big Island, and scientists gave you a 2-week warning that Mauna Loa was about to erupt. Would you evacuate immediately, or would you stay and wait to see where the lava goes? Drop your answer in the comments. There's no right answer here, and I genuinely read every single one. If this video made you think differently about the ground beneath your feet, hit that like button. It takes 1 second, and it helps more people find this channel. Subscribe if you're new here. This channel is about the science of the world we live on, the things we know, the things we're still figuring out, and the moments when the Earth itself reminds us who's really in charge. Kilauea will erupt again. Be here when it does.